Okay. Once again, I welcome you all to the live session for NPTEL course Advanced Concrete Technology. I've already shared my screen. Okay. Good evening all who join now. So before going to the live session, let me explain you how to give your answer in polls. So to the bottom right corner of your screen, there is an option called activities. Okay. So if you click that, there will be 4 options. Out of that, if you click polls, you'll find questions already launched. You can give your answers there once we start discussing the questions. So, or else if you're not able to find polls, or if you're not able to give your answer in polls, you can give your answer in chat box. So the people who are using mobile phone and have joined the live session, please, there is a option here called more options. In mobile there will be 3 dot. If you click that, uh, we can find activities and polls here. Okay, so let me start the live session now. So this is a week 7 live session for Advanced Concrete Technology course. So I hope I'm audible to all. So now moving to first question of this week. In this particular week content, this is second part of mineral admixture. So in the last session, in the last week class, sir has explained about how fly ash, GBFS, how we can using them in concrete reduces carbon dioxide emission, and then it reduces energy, and then it's beneficial for the environment. It increases the durability as well. So in this week, we'll further be discussing about the reactivity assessment techniques, and then how does durability increases by using pozzolanic additives, and how we can replace more than 50% of cement with pozzolanic additives or supplementary cementitious materials. So the first question is this: ratio of alumina to silica in metakaolin is. So everyone know metakaolin is the calcined kaolinite. So kaolinite is the rock clay. So it will be calcined less than calcine temperatures less than 1000 degrees Celsius to convert kaolite into metakaolin. So kaolite will be a more or less the crystalline structure. It is not reactive, but calcined clay, metakaolin is it's in reactive form. So here the question is the ratio of alumina to silica in metakaolin is. Let me start the timer for a minute, and we'll see the answer after a minute. Please give your answer in polls. Your name will not be shown here who gives which answer. Please, I request everyone to give your answers. Let's see how much you're able to follow the class. And before coming to the class, I request everyone to watch the videos and come here. Alumina is nothing but Al2O3, alumina oxide, and then silica is nothing but silica SiO2, silica dioxide. Time is up. Let me stop sharing the screen. So let's see the class response. To the people who join new, to the bottom right corner of your screen, there is an option called activities. If you click that, you can find polls. In polls, I've already launched the question. Please give your answers in polls. Only 3 out of 7 people have given your answers. Please, I request everyone to give your answer in polls, or else you'll be simply sitting in the class and you'll be not able to engage with the class. So I request everyone to give your answers. Okay. I'll check in the chat box as well. Okay, good evening. Okay, you have given B and C. Okay, but C is the correct answer is nothing but C. The ratio of alumina to silicon metakaolin is 1 is to 2, because generally if you write in a stoichiometric formula, general formula for metakaolin is S2, which is nothing but alumina and then 2 silica. So it's nothing but, so when this metakaolin is added to cement concrete, so we know that cement OPC hydrates to form CSH and then Portlandite. There will be Portlandite particularly in the ITZ zone. So once we add this metakaolin, the reactive form of a reactive form of alumina and silica reacts with the Portlandite to form additional CSH. Okay. Now let's move to question 2. It's a 2 of us question. So I request everyone to give your answer. It's not going to be complex at all. Either it's going to be option A or option B. So please give your answer in polls or at least in chat box. The question is, in blended cement systems, as the replacement level of mineral admixture increases, the carbonation depth decreases. Okay, I'm repeating the question. In blended cement systems, as the replacement level of mineral admixture increases, say increasing from 10% to 20%, assuming that replacing OPC with fly ash from 10% to 20% we are increasing. What will happen to the carbonation depth of that particular binder? Let me start the timer now. After a minute, we will see the answer. If you have one concrete with 10% fly ash replaced and then one more cement concrete with 20% fly ash, we have increased the replacement level, right? What will happen to the carbonation depth once we increase the replacement level of the mineral admixture? Sir has generally compared what is the resistance to chloride and then carbonation for different types of binders, comparing with OPC, fly ash, slag. Uh, so if you have watched the video, you must know the answer. Okay, it's already time up. Shall I stop sharing the screen? Okay. Okay, false. False, false. Okay. Let me check in polls as well. Let me end the poll for question 1. Okay, 4 of you have given answer as false. Thank you. Let me end the poll now and get back to the PPT. So as you guys said, the correct answer is false, because the see, we know that cement hydrates, OPC hydrates to form CSH and then Portlandite. That Portlandite, once carbon dioxide comes from the environment, from the atmosphere, the Portlandite reacts with uh, carbon dioxide to form calcium carbonate, which forms a hard layer outside, and further the penetration of carbon dioxide is stopped with the formation of calcium carbonate once the carbon dioxide reacts with Portlandite. But when it comes to blended cement system, the added reactive alumina from the pozzolanic additives, that is mineral admixtures, uh, will react, the reactive element silica will react with the Portlandite and it will form additional CSH. So there will not be any Portlandite available for the carbon dioxide to react with. So the penetration depth increases once we replace the OPC cement with mineral admixtures. So the answer is false. The carbonation depth increases. Okay, so this is where sir has compared OPC with slag, class F fly ash and then class C fly ash. Comparing with chloride penetration, OPC performs very bad, but compared with slag and fly ash, both performs very good. And then Coming with water solubility, again blended cements perform better, and then coming with gas permeability also blended cements perform well, but only when it comes to carbon dioxide penetration, OPC performs better because of the availability of Portlandite. Now let's move to question 3. This is also again it's going to be a true or false question. I request everyone to give your answer in polls or at least in chat box. The question is, the addition of lime or cement to geopolymeric mix leads to polymerization at ambient temperature, which means so to prepare a geopolymeric concrete, we generally need high temperature for the reaction to happen, but they are saying once we add lime, calcium oxide, or cement, lime in the sense it can be lime means can be calcium oxide or hydrated lime, calcium hydroxide, or cement to geopolymeric mix leads to polymerization at ambient temperature, which is saying that we can even formulate the binder even at room temperatures. This is the question. So after a minute we'll see the answer. Is it true? With the addition of lime, can we prepare a geopolymeric mix at room temperature? Is it possible? If it give true, or else if it's not possible, then give false. I request everyone to give your answer in polls. To the bottom right corner of your screen, there is an option called activities. If you click that, you'll get to polls. Time is up. Let me stop sharing the screen. This question 3. Okay, the answer is true. You guys are given true. Let's see in the chat box as well. Yeah, it's true. The right answer is true. Thanks for the response. Now let's get back to the PPT. So here, coming to this particular snap is from the lecture. So in particular to geopolymeric concrete. So we need an aluminum silicate. Either it can be fly ash or metakaolin or blast furnace slag, rice ash, any aluminum silicate material, and then it's mixed with alkali activators. Mostly it's sodium hydroxide or potassium hydroxide along with potassium silicate or sodium silicate solutions. So once we both mix it together, we formulate a mixed design and then we cure it for some time. And then we cure it at elevated temperature without the addition of calcium or calcium oxide or calcium hydroxide, or as if it's blended with cement or calcium oxide or calcium hydroxide, it can be cured at ambient temperature. Possibly even with slag systems, it has more than it is up to 40 to 50% of calcium oxide in it. It's possible to formulate geopolymeric binder with blast furnace slag at room temperature itself. I hope you guys got it right. Now let's move to question 4. So this question is a bit complex. Let me read it out and explain it, and I'll give you time. Then you can give your answers. Question 4 is, in a ternary blended system, binary means 2. So in more than 2, it's ternary. In a ternary blended system that has cement, limestone, and an SCM. Okay. Let's assume it can be a metakaolin. Okay, as explained in LC3 cement. So I hope you guys have already watched the video. Like LC3 is nothing but a ternary binder with cement of 50% of cement with 15% of limestone and then about 30% of metakaolin. It's a ternary blended system. The hydration products formed, which are different from that of OPC. If it's 100% OPC binder, then we are comparing it with the we are comparing the ternary blended system with OPC. The hydration products formed that is different from OPC is that cash. So in OPC, what is hydration product formed? Can someone say major hydration product? Yes, you know it. If OPC reacts with water, OPC hydrates. What is the major hydration product formed? It's Portlandite or CSH. What is the major hydration product? Am I audible to all? Just a minute. Am I audible to all? Okay, CSH. Fine, thank you. Since there is no sound in the class, uh, if someone is interested to unmute and answer, please unmute and answer. Thank you. I didn't know whether I'm audible or not. Sorry. Yeah, it's CSH, right? So when it's completely OPC blended, it's going to be CSH. But if it's a blended system, obviously it has both reactive silica and reactive alumina. So the hydration product formed is CaSH. And then additionally, there are some more hydration products formed. That is A and B that you have to identify, both A and B. And A and B are similar to the phases formed in OPC. So if it's only OPC, there is a particular phase formed. Okay, either it can be from these four options we can see either it can be AFT or AFM or hemihydrate or AFM. But if it's a blended system, it's not going to be AFT or AFM in any case. That's going to be different. That you have to find it out. Okay, let me start the timer now for a minute. Then we'll discuss the answer. You have to find the alternate hydrates formed with ternary blended system in place of the phase that is given as the third option here in all the options. Which phase? You know that CaSH is formed in the alternate ternary blended system, but in OPC it's CSH. So similarly, you have to find what are the hydrates formed in ternary blended system, which is similar to the phase formed in the OPC system. And there is a note that A and B are interchangeable. Time is up, but let me wait for some 30 seconds and let's see the response. Please give your answer in polls. If you have any doubt by any point of time, you can stop and ask. If it's not relevant to this question but it's similar, you can stop by my any time while discussing the question, or even after discussing all the questions, we can have 5 to 10 minutes to discuss your queries. Okay, let me stop sharing the screen. Okay, D. Let's see what's the answer in polls. Let me end the poll for third question. Coming to question 4, some of you have given option D, some of you have given, one person have given option B as well. So let's see what's the right answer then. So the correct answer is, so here is the explanation. So if it's a ternary blended system or binary blended system, compared to CSH, CaSH also will be present. So compared to, and additionally there will be CSH also, because Portlandite reacts with the additionally added reactive alumina or silica. So there will be increased CSH as well as CSH in blended systems, and then there will be increased carboaluminate phases because there is reactive alumina from metakaolin, right? So that will form uh, mono or hemicarbonate in place of monosulfate, and more ettringate will be stabilized uh, once we add limestone and metakaolin to the cement system, because uh, once there is limited availability of sulfates, so ettringate converts to monosulfate now. Since we have additional carboaluminates available in the system, carbon dioxide from calcium carbonate, so that will react with the aluminates from the metakaolin added to form the carboaluminate phases, so which stops the conversion of ettringate to monosulfate. When the availability of sulfate decreases, there is a conversion from ettringate to monosulfate in OPC system. Since we have additional carbonate and aluminate from the system, so it forms carboaluminate phases. So the conversion of ettringate to monosulfate is uh, stopped to a certain extent in this particular system, ternary blended system, with limestone and cement limestone and the metakaolin. Okay, now let's get back to question 5. Please give your answer in chat box. Question 5 is very simple. If you know the chemical composition of limestone calcined clay cement, then you will know the answer. Limestone calcined clay cement LC3, which is called as LC3, shows enhanced chloride binding capacity. Let me start the timer now. So it says that it has enhanced chloride binding capacity. The hydration products from LC3 cement will react with the chloride coming from the surrounding environment, and it will hold chloride with its hydrates. It binds the chlorides from the environment, which enters the concrete. Is it true or false? You can compare it with OPC and give your answer. Time is up. Let's check your response. Let me end the poll here. Okay, limestone calcined clay. Okay, you have given true. Okay, 2 of them have given answer. Okay, okay, more people have chat give your answers here. Yeah, it's true. Only 5 people have given your answer. 3 in chat box and then 2 in polls. I request everyone to give your answers. Okay. Now, so the correct answer is true. Coming to chloride penetrability by RCPD test and as well as migration test. So which says that here they have compared OPC with OPC replaced with 30% fly ash, and then coming to LC3 it's 50% OPC and then 15% limestone and then 25% metakaolin and then 5% gypsum. Sorry, 30% metakaolin and then 5% gypsum. Totally it makes the replacement makes up 50%. So it says that it has excellent resistance to chloride penetration by combined transport properties because the reason majorly is the alumina present and the reactive alumina from metakaolin. Particularly metakaolin has both reactive silica as well as reactive alumina. So this reactive alumina binds with the chlorides from the environment and forms Friedel salts. So which is similar phase to AFM and AFT. So which is a non-expansive salt. So it does not cause any damage to the system. If you compare sulfate attack, the additional sulfates from the environment when it enters the cement system, it reacts with the monosulfate phases, then it forms ettringate. So ettringate is an expansive phase. So compared to when comparing chloride and sulfate attack, uh, from floated attack, if you have reactive alumina, the Fredel source will be formed, which is a non-expansive one. And if we compare on the scale, same with sulfate attack, ettringite forms on sulfate attack. So it is, which is an expansive hydration product. So expensive sulfate attack product. So obviously it causes cracks. So limestone calcined clay cement has better binding capacity. Now let's move to question 6. Question 6 is the unburnt carbon and the agro-based pozzolans. Agro-based pozzolans is nothing but rice ash, sugarcane bagasse ash, wood biomass ash, uh, corn cob ash. There are many more ashes, but in the class there are discussed about rice ash and sugarcane bagasse ash. So the unburnt carbon in the agro-based pozzolans affects the air entrainment adversely. So it says that if we add air entrainment admixtures, the efficiency will be very less. Is it true? If we have more unburnt carbon in the system, it will affect the air entrainment efficiency. Is it true? Please give your answers. We'll see the explanation after a minute. I request everyone to give your answer in polls. Time is up. Let me stop sharing the screen. Okay, some truths here. And then let me check in polls as well. Okay, you guys have given the correct answer this time. Congratulations. Now let's get back to the PPT. So from here I can understand that you guys are following the lectures very well. So normally these, just a minute. So these biomasses are burnt in small scale industries, like either it can be sugarcane bagasse ash, sugarcane mills, and then modern rice mills or paper industry, where they burn this locally available rice husk or sugarcane bagasse or any other agro-based biomass to for energy generation, right? So uh, so because burning this kind of agro-based biomass is encouraged, because it's kind of a renewable type of energy source, because everywhere we are going to do farming again and again, so it falls under the category of renewable energy source. So orange usually contains a large amount of unburned carbon, which may adversely affect air entrainment. But can we say if it's rice is burnt in a controlled environment at proper temperature, say from less than 700 degree, 600 to 700 degrees Celsius for residual time of 2 to 3 hours with proper supply of air, can someone say will we have more unburned carbon in the resultant ash? Can someone unmute and say? I could not hear your voice. Okay. So if we burn rices in a controlled environment uh, from 600 to 800 degrees Celsius at with proper residual time, with supply of oxygen as well, like fuel air, we should supply air as well. And then if proper supply of air is there and burnt at particular time, and then particular if you know at what temperature it burns properly, so the unburned carbon will be very less in the resultant ash. But these ashes are burnt in these industries where we don't have this proper temperature is not maintained. So if it is burnt above 800 degrees Celsius, then there will be recrystallization of silica, which will form from amorphous state. It will convert into cristobalite or tridamite type of crystallite silicas will be formed, which will obviously reduce the reactivity. And in case if it's not properly burned, if it's burnt at temperatures less than 600 degrees Celsius, then there will be obviously the presence of unburnt carbon. So this unburnt carbon will be present if it's not properly burnt. So the correct answer is true. It affects. So when unburnt carbon is there, once we add this so not superplasticizer, even if unburnt carbon is present in the pozzolan, then we need higher dosages of superplasticizers to increase the workability as well. And when it comes to air entraining admixtures also, the unburnt carbon tend to absorb most of the absorb these admixtures, and it obviously reduces the efficiency of the air entrainment. So when unburnt carbon is present in system, obviously if you add admixtures, it will it will reduce the efficiency of the admixture. Either it can be superplasticizer or air entraining admixture. Now let's move to question 7. Question 7 is, bagasse ash is richer in silica content when compared to rice ash. Have you gone through the chemical composition, oxide composition of bagasse ash and rice ash? It's already there in the lecture as well. I've already started the timer. Please give your answer in chat box or polls. Time is up. Let me stop sharing the screen and check your response. Okay, 1 true and 3 false. Okay, let's see what is true and what is false. Okay, more false from chat box. Let me end the poll here. So this is one of the diagram taken from the lecture, so which is by Martina and Monzo. So here we can see the purple color here indicates ash percentage. If we burn bagasse, so this is the ash percentage that we can get. This is around say 15%, and if you burn rice husk, more than about 22% of the rice husk is received as rice husk ash. And about the ash, there is about 70 to 75 percentage of silica, and coming to rice husk, it is more than 90% it's silica. So bagasse is not richer in silica when compared to rice husk ash. So the answer is false. You guys have already given the correct answer. Now let's move to question 8. Let me start the timer. So here the saying, as the formation factor decreases. Formation factor is one of the factors used to measure durability. So here the saying, if formation factor decreases, the durability of the concrete increases. Is that true? Please give your answer in chat box or polls, whichever is convenient for you. But please give your answers. In polls, your name will not be revealed, but in chat box, your name will be revealed. Whichever is convenient for you, please give your answer. But here, no one is going to read your name. I'm just going to see the answer and I'll check the response. What is the class? How much you guys have understood the topic? Time is up. Let me stop sharing. Okay, 3 votes as true and then 1 vote for false. Okay, coming with, okay, mixed response for this question. Okay, then we have to discuss. The correct answer is nothing but false, because formation factor here, uh, if let me here is a plot explaining porosity versus formation factor. If porosity keeps on increasing, the formation factor decreases here, right? So if porosity decreases, the formation factor increases. So can someone say, is porosity good for durability or not? Increasing porosity is not directly related to durability, but permeability is related to durability, right? So can someone say what is the difference between porosity and permeability? Maybe in chat box at least, because you guys are not unmuting and discussing in class. At least in chat box, can someone type what is the difference between permeability and porosity? Let me type here. Yeah, porosity voids. Okay, permeability dash. Okay. I think you got confused between pores and voids. Voids are discrete, so it's not continuous. But pores is a continuous. Pores is a continuous one. So okay, let me make it clear. So porosity means, we can say, uh, there are some voids in the system, or pores. Uh, like either it can be filled with water, or it air filled porosity or water filled porosity. But when it comes to permeability, it's connected porosity. Unless pores are there but they are not connected, then no problem. But if pores are there but they are connected, then permeability will be there. Permeability is dangerous to, I can't say dangerous, but it's not good for durability. Ability of the substance. Uh, okay, porosity is tiny. Okay. See, we need not discuss about any surface or thing. Just think about a cube concrete. Just not think about only surface. Okay. So I think I will not be able to draw properly. So
Ma'am, the best example for permeability is a sponge, ma'am, because all the pores are interconnected to each other. If you
yeah.
put a drop of water on top of the sponge, it will percolate and it will come down at the base.
Okay.
So that's
Thank you.
why sponge is so soft. So you can tell that as a weak structure. It doesn't have a durability. So permeability is basically interconnected pores.
Yeah. Uh, unless yeah, the pores are not connected, there is not going to be a problem. As sir said, permeability is connected porosity. So then water can easily percolate to the concrete, and then it will, along with water, water will not only come, there will be chlorides, sulfates from the environment. Obviously, it is detrimental to the structure. Chloride is detrimental to RCC structure. Sulfate is detrimental to the cementitious system as itself. So sulfates will react with monosulfate and it will form etringate, and it is an expansive sulfate attack product. Then it will create cracks. And again, once crack is formed, then obviously it will allow more like chlorides and sulfates. Again, it's going to detrimental the structure. It's going to affect the structure. So permeability is dangerous to structures durability, concrete durability. And coming to here, back to porosity and then here. So once porosity keeps on increasing, obviously the connectivity is also increases, right? So here they have marked with porosity to formation factor. So with porosity, once porosity keeps on decreasing, the formation factor increases, which means uh, assume this is a concrete cube. Okay, let me draw a concrete cube here then. Let me draw two concrete cubes. Let's take it as A, and then next one as B. I think sir has given this example already in class, I suppose. Okay, this is A, this is B. Okay. So now let's assume this is the porosity of the structure. This is how the water from the environment reaches. Water from here reaches the concrete core. Okay, and for concrete B, this is the path. Okay, so okay, let me draw it here till here, so we can compare both. Okay. Can someone say which concrete will have more formation factor, A or B? Okay, which is I don't know how to say. Okay, if water comes from here, okay, from here or from here, which from which in which concrete water will easily reach the core, either A or B. If water comes from the surface, in which concrete it will reach the core fast, either in concrete A or concrete B. I didn't see any response. Maybe you guys are typing in chat box. Okay, most of you have typed as B. Yeah, it's true. In concrete, I asked which one will reach fast. So in concrete A only water will reach fast because it need not travel much. It just enters here and it comes here. But when it comes to B, the path is very it's a longer path. So first the water has to travel from here to here, then only it will reach the core. So obviously it will take more time for the water in concrete B to reach the core. So the correct in which concrete will reach the core fast is option A. It's not B. So this is the one which means we measure the tortuosity. Tortuosity is nothing but the complexity in reach for the contaminants to travel to the concrete. So here the complexity is very less, but here it's very complex. So the formation factor for this concrete will be much higher, and then for concrete A will be much lesser. So with formation factor, increase in formation factor, obviously the durability of the concrete will increase because the path taken by the water from the environment or contaminants from the environment to travel through the concrete will be much higher if the formation factor is higher. Okay, so with finer fly ashes and calcined clay, the formation factor seems to be much higher, signifies higher resistance to the ionic transport in the system. So if we calculate formation factor for concrete A and concrete B, formation factor will be higher for concrete B, not A. And then water will reach easily the core in concrete A. Does anyone feel or what I said is wrong, or you guys are not able to follow? You can just unmute and ask me. Okay. So if you guys have any more doubt, you can ask me by the end of the class. Okay, this is question 9. Agro-based ashes, say it can be a rice ash or sugarcane bagasse ash, has more alkali oxides than coal-based fly ash. Okay, let me start the timer now. So I guess you have seen the chemical composition of coal-based ashes and as well as agro-based ashes from the lecture. So my question is, agro-based ashes has more alkali oxides. Is that true or it's false? Please give your answer in polls or chat box. Time is up. Let me stop sharing and then check your response. Okay, some people have given true. Coming to polls. Okay, more true and less false. Let's see what's the right answer. So here we know that we are burning the agricultural waste residue. When it comes to sugarcane bagasse, it's an agricultural residue, right? Once they get all the juice out of the bagasse, they throw it out as a waste. And then coming to rice husk also, it's just the outer cover covering the rice. So it's just from the plant. So plants tend to absorb potassium from the soil, and then it will keep storing in a plant, right? So obviously the potassium content uh, will be much higher in agriculture residues. So obviously the potassium oxide also will be in much higher percentage compared to coal-based fly ashes. The correct answer is true. I hope you guys got it. Now let's moving to question 10. Question 10 is an assertion reasoning based question. The assertion is the aluminosilicate based inorganic additive mostly used in ternary blended system is calcined clay. We are saying we know there are different aluminosilicates, say fly ash or uh, GGBFS, uh, calcine clay. All these are aluminosilicates. The aluminosilicate based inorganic additive mostly used in ternary blended system is calcine clay. And then the reasoning is calcine clay has most reactive alumina at a significant proportion. So this is the reasoning. So if you find both, let me start the timer now. If both assertion, reasoning and true, and reasoning is the proper, R is the proper reasoning for A, then you can pick option A. And if you find R is not proper reasoning of A, then you can pick option B. Similarly, if A is true and R is false, C, then A is false but R is true, then it's D. If both you find as false, then give option E. I've already launched this question in polls. Please give your answer in polls or please type your answer in uh, chat box. Time is up. Let me stop sharing now. Okay, most have given option A Okay, let me end the poll and check your response in chat box as well. Okay, the one option E, remaining everyone have given option A. Let's see what's the right answer. So coming to the answer, I have not given any snaps from the lecture for this question because it's very difficult to give the answer from the lecture from a particular slide, so I didn't give any explanation here. So the coming to aluminosilicates, they are saying if it's going to be a ternary blended system, the mostly used aluminosilicate is nothing but calcined clay, because calcined clay has both reactive silica as well as reactive alumina when compared to fly ash. In fly ash, the reactive silica content will be much higher compared to reactive reactive silica content will be higher in fly ash, but in calcined clay both reactive silica and reactive alumina will be present. So when it comes to ternary blended system, we are going to replace more cement, uh, more than uh, more than 20-30%, right? When it's going to be ternary blended system. If it's a binary blended system with fly ash, how much we replace? Normally from 25 to 30%, right? So in that case, it's fine. But if it's going to be ternary blended system, then the replacement will be around 40 to 50%, right? So then in that cases, if we replace much non-reactive thing, then it's not going to help you with formulating the binder. So we need a reactive system. So calcined clay has both reactive silica and reactive alumina. That is the reason uh, why we go for calcined clay for ternary blended system. So the reasoning is calcined clay has most reactive alumina at a significant proportion. That's true. Okay, now let's move to question 11. Question 11 is, which of the following methods are used to assess pozzolanic reactivity? So, sir has explained about the different techniques used to assess pozzolanic reactivity. You have to find which of the following methods are used for assessing pozzolanic reactivity. There are 5 options. Option A is strength activity index test, and then option B is fraternity test, and then option C is lime reactivity test. Option D is both A and B, and then option E is all of the above, which is nothing but A, B, and C. Now let me start the timer. After a minute, we'll see the solution. All of the above in the sense it's not A, B, C, D, it's A, B, and C. So we know that a material is a pozzolanic material, say it's a fly ash or GGBFS. So how will you know what is the pozzolanic reactivity of the material? Pozzolanic reactivity is nothing but the reactive silica or reactive alumina from the pozzolanic material, say it's fly ash or GGBFS, will react with the Portlandite from cement hydration and then react to form additional CSH, right? So to measure that reactivity, pozzolanic reaction, how to assess that pozzolanic reactivity, which of the following methods are used? Time is up. Let me see your response. The questions will be MCQ type and then as well as not descriptive, but you need to, there will be fill in the blanks as given in the assignments, but most probably it will not be descriptive because uh, most number of students will be taking the exam, so it's difficult for correcting descriptive type of questions. So as I know, up to my knowledge, it's going to be fill in the blanks as well as MCQ type questions. Okay, mixed response here. Let me check polls once. Okay, someone has given fraternity test and then someone has given, few more of you have given all of the above. Okay, the correct answer is all of the above. Is direct from the lecture PPT. So here they have given few of the methods which are used for measuring pozzolanic reactivity. which is strength active index test, and then electrical conductivity method, fraternity test, lime reactivity test, lime saturation test. All these methods are used for measuring the pozzolanic reactivity. So the correct answer is all of the above. The final question is match the following. So here you have to match the items in the left section, the things in the right side column. So here there are four different options: irregular bagasse ash particles, and then if you remember the lecture slide, they have sieved the bagasse ash, has received bagasse ash from the sugarcane plants. So once they sieve it, they got irregular bagasse ash particles and then fibrous particles, two types of particles. So you have to match it with the things in the right side column. And then third is spherical particles, and then fourth one is the prismatic particles. What is the difference between these two? What does this spherical particles mean? What does prismatic particles mean? Let me start the timer now for 2 minutes. So after 2 minutes, we'll see the answer. Please type your answer in chat box. I have not launched this question and polls. In the meantime, if you guys have any other doubt, please type in the chat box or you can unmute yourself and ask.
Ma'am, two doubts, ma'am.
Yes, sir.
Ma'am, firstly, this non-graded papers are there in the assignments, ma'am.
Yeah, yes, sir.
Ma'am, can't it be combined with the same, like the assessment one only, ma'am? Why this non-graded part separately and the assignment separately, ma'am?
This is for your practice.
Okay, ma'am.
This is for your practice, and then like the people who have joined, I think more BTech people and MTech people have also joined the course. So for the BTech people, it will be more easier for to understand how the assignments are evaluated if you once go through the non-graded assignments, and then you can attempt the graded assignments.
Ma'am, secondly, ma'am, I had put a query in the question forum, ma'am. Few questions are having like 2 to 3 correct answers.
Yeah.
And by suppose, ma'am, out of the three, I attempt only two.
Yeah, I think I've read your. I think I've read your query. Okay, yeah,
And
tell
then it
me.
says wrong. It gives 0 marks, ma'am. But that is not fair, ma'am. Actually, at least two were correct out of the three. So it can't be completely wrong attempt or the wrong answer.
They're giving you zero, right? That
They
is
are
what
giving
you.
0, ma'am. Yes, ma'am.
Okay,
Because
can you also specify the question
there
for
are
which
many,
you
ma'am.
got that?
There are many, ma'am. Like in assignment 5 and 6 also. Like if four were correct or three were
I'll
correct.
just check with the NPTEL team and get back to you.
Yes, ma'am. Because it will be beneficial for others also, ma'am. Like at times it might happen that I feel three are right or two are right, but I attempt only two of them and I didn't attempt the third one. But the
But
computer,
okay, even if okay, if say that there are A, B, C, D, and E. Okay, or let's assume 1, 2, 3, 4, 5. If option 2 and 3, 2, 3, 4 are right, but if pick up 1, 2, 3, you'll get 0 marks.
yes, ma'am, that is true. If I pick up one, it is wrong. But if it
Yeah,
is 2, 3, 4 answer and
yeah,
I pick up only 3, 4 and I leave two,
yeah.
then it gives 0 marks, ma'am. I have
Okay.
not attempted a wrong one, but out of the three correct, I
Yeah,
attempted only two.
you left one right one.
Yes, ma'am.
Okay.
So the computer goes purely by the strings, ma'am. So it is at times little bit of I'll not call it as unfair, but little bit of unfair, ma'am, in that.
Okay, sir. I'll discuss with the NPTEL team and I'll get back to you in
Okay.
the discussion forum.
Okay, ma'am.
Okay, sir. Thank you. Okay. So let's see your answer in the chat box. Okay. CAB. Most of you have typed the same answer. Okay. Now let's see the solution. So here is the answer. CABD. That's the right answer. So irregular Bagasash particles, in the sense, it's mostly that if you compare the ashes from agro-based source and then coal-based fly ash, coal-based fly ash should be more or less spherical in nature, but when it comes to agro-based biomass ashes, it's going to be irregular, obviously. So irregular bagasse ash particles indicates it has reactive silica particles in it. And when it comes to fibrous particles, if you see bagasse ash particles, if they sieve it through 300 micron sieve or 600 micron sieve, the fibrous particles will be coal. There will be coarse fibrous particles, which are nothing but unburnt inorganic materials like unburnt carbon. And when it comes to spherical particles, it indicates condensation from gaseous state. So once it burnt, it will fly. So once it flies off and then it's collected in the electrostatic precipitators like in the fly ash. So more or less, once condensation happens from the gaseous state, it will form more or less spherical particles. And when it comes to prismatic particles, it indicates crystallinity. More or less, crystalline particles will be prismatic in nature. So this is the answer. I hope you guys have already given the right answer. If everything is done, let's find up the session now. If you guys have any query, you can wait and you can ask the question, or else you can leave the class. Thank you all. I request everyone to unmute yourself and give some answer if I ask something. Thank you, sir. Uh, so, or else it's very difficult to continue the class. I don't know whether you guys follow or not.
Actually, in the last class also, like I brought out to Anupama ma'am,
Okay, sir.
these last three chapters were little bit of more of chemical nature. So I think it was little bit of difficult to understand because there's a lot of many aluminate, silicates, and everything going on everywhere, ma'am.
Okay.
So I think that's why the response might be less because I was also going through the notes and studying what sir is giving this video. So now I think from session week 8 it will be more interesting, ma'am, of the mixed
Yeah,
design
it's,
and
yeah,
the
it's going to be mixed design, fresh
fresh
concrete
concrete. So
properties.
I think that will be more this thing because this right from week 3 we have been into this only, ma'am, mineral admixtures and chemical admixtures and
More into
everything.
cement chemistry.
It's completely chemistry and it's only aluminate and silicates which were there in the mine, ma'am. That's what.
Actually, that is the one. That is the one which is controlling the durability of the cementitious system. So, uh, people are unaware why we are adding fly ash. They think that adding fly ash reduces strength and it's not good for cement concrete. But in opposite way, it's actually good for the cementitious system. And it enhances durability. People does not understand. They think that we are adding fly ash to reduce the cost, but that's not true. Obviously,
Yes,
reduces cost. That's an added benefit, but obviously, it increases the durability of the system.
in the last session also I brought out, ma'am. I'm trying to prepare a chart, ma'am, which will make it very simpler. Like on the left hand side, I've made all the mineral admixtures which are there,
Okay.
and then I've made a column for the chemical composition of it, and with respect to its effect on the durability of concrete and the other factors of the concrete, whether it increases or decreases. Some sort of thing I'm preparing, ma'am. It will take some time for me, about a week or 2 weeks. I said to Anupama ma'am also. So by after 25th, I think I'll be able to prepare that, and if required in the class, I can show that, ma'am.
Okay, sir. Thank you. And you said something, right, regarding sponge, porous. So, sponge
I
is
mean,
porous,
this,
but it's not
it
soft
was
because of its
no, it's a
porous.
comparison, ma'am. It was just a comparison that the all the pores are interconnected from in a sponge, ma'am. If you
Yeah,
just drop water, it will just seep in.
yeah, but it's not soft because it's porous. Because the material itself is a mm,
Ma'am, I understood that. I
Yeah.
was just trying to bring out the action of water traveling,
Yeah.
ma'am.
Yeah.
That is what you were
Water.
trying to,
Yeah.
because
Transport
porosity,
mechanism is true. Whatever you said.
porosity and permeability, we can have this example sort of thing.
Yeah. Because concrete also that we have a aerated concrete, porous concrete. So that will be hard enough, brittle. It's not going to be soft. But obviously, when it comes to transport mechanism, it's going to follow the same thing. Okay. Thank you. Let me stop the class here and stop recording as well. Thank you all.